Alright, so last lesson we looked at graphing transformations of y equals sine x and y equals cosine x, and we did so by taking some key points that were on the parent function. So if, let's say we looked at sine x, we looked at 0, 0, 90 degrees 1, 180, 0, 270, negative 1, and 360, 0. And we transform those points using a mapping rule to give us image points on a new graph, which we could then use to create our transformed function. Okay, we did the same thing with cosine x. We could take our key points here. And you'll notice here for both of these functions, our key points were the points that are either on the axis, at our maximum, or at our minimum. Okay? And it's going to be really important. I've stressed this before, I'm going to stress it again. You really need to know how these graphs behave. Okay? And because what we're going to be looking at today when we're graphing, we're going to look at a slightly faster way of graphing. It's going to involve isolating an entire cycle of the graph. For example, a cycle going from here to here, or on cosine x, a cycle going from here to here, and being able to graph a cycle of that graph that transforms. So we're going to need to know where the key points in the cycle are. In the case of sine x, we know the cycle starts on its axis and goes up from there. We need to look at the fact that for cosine x, the cycle starts at its maximum value of 1 and then goes down. So all these ideas are going to be important going forward, and we need to know those graphs very, very well. Okay, so before we get into that though, let's do a couple of review questions here. So if we look at the a sinusoidal function, so again, sinusoidal means it's a transformation of sine x or cos x. What feature is affected by a horizontal stretch? Is it the symmetry, the period, the amplitude, or the axis of the curve? Okay, so if it's a horizontal stretch, well, let's take a look at a picture. Okay, so what I've graphed here is a transformed version of the sine function. And if we're looking for the horizontal stretch, that came from the k value right here. So see what happens if I change the k value. Well, what do you notice here? You'll notice that it becomes, again, more stretched and more compressed horizontally, so it affects how long it takes to go through a cycle. Okay, it affects how long it takes to go through a cycle. That's going to affect the period. Okay, let's try another one. So which feature is affected by a vertical stretch? Well, a vertical stretch, again, let's take a look at the graph. Vertical stretch would be changing my a value right here. You see the axis doesn't change, the period doesn't change, still takes 360 degrees to complete a cycle, as you'll be able to see there. What does change though is the amplitude. So our maximum value, which was at 1 originally, has now gone up to larger or smaller values. Okay, so it's the amplitude that's affected by the vertical stretch. Okay, if we're talking about a vertical translation, well, let's take a look. Vertical translation, that was my Q. Okay, that takes the entire graph and shifts it up or down. What's that going to affect? Well, that's going to affect the axis of the curve. Okay, remember the axis is that invisible horizontal line that cuts the graph in half. And if we do a horizontal translation, what's going to be affected? Well, let's take a look. So it's amplitude, axis of curve, symmetry, or period. Okay, let me just reset these to their original values here. Okay, now if I change the horizontal shift, okay, you'll see it moves a little bit left to right. Okay, and I can move it on further if I expand these values right here. Okay, and you'll see that the axis doesn't change, the amplitude doesn't change, the period doesn't change. It still takes the same amount of time to complete one cycle. But what's going to be affected here is the whole idea of symmetry. Okay, so right now, if you take a look at this being a sine graph, you can sort of see it's symmetric if you look at it going across the origin here, sort of like a mirror image, or reverse mirror image. If I change this by shifting left to right, that's not exactly preserved anymore. So the only thing that's really affected there is a symmetry, which isn't really that big of a deal. Okay, and last but not least, if you're going to look at the range is going to be affected by what? It will be affected by a vertical translation, a vertical stretch, both A and B, or just a horizontal shift. So we're talking about the range, that's talking about the y values here. So if I do a horizontal shift, you'll see that the y values don't change. Okay, if I do, oh sorry, that's a horizontal stretch. If I look at a vertical stretch, you'll see that the range of different y values changes. And if I shift it up or down, the range of y values changes. So this is affected by both a vertical stretch and a vertical translation. Okay, so again, to recap what we did last class, we graphed transformations using mapping rules, key points, and image points by using the mapping rule. What we can do instead, and again, I'm not going to force you guys to use one way over the other, but this could be a potentially faster way instead. If we remember that all the key points that we chose in the sinusoidal function always occurred at the maximum, minimum, or on the axis, then, well, if we just know where those key points are going, then we have everything that we need to create our new graph. Okay, so your first thought might be, well, that's exactly what we did before. We took the key points, found the image points, but we can actually figure out where all these key points are going to go using values such as the axis, the amplitude, the range, and, the period. So if we can find all that from the equation, we don't need to create a mapping rule. We can just actually find where those points go and create our sketch. Okay, so what we're going to do is we're going to take these key points. I think you might notice here, if we split up our graph into 4 quarters, in fact, this might be easier to see from our first graph here. Let's take a look, let's just the blue one here, the y equals sine x. If we split our graph into quarters, going from the axis up to the maximum, okay, the maximum down to the axis down to the minimum, and minimum up to the axis, we now have our cycle broken up into 4 sections. 1, 2, 3, 4. Do the same thing for cosine, right? Max to axis, axis to min, min to axis, axis to max. You can split an entire cycle up into 4 quarters of equal length. So again, these are all things we can do to potentially save ourselves some time. So I'll show you how to do that here. Let's take a look at an example together. So here's a function, -3 sine bracket x minus 30 degrees plus 7. And what we're going to do here is we're first going to figure out everything we possibly can just by looking at the equation. Okay, so I want you to try and do this part of try and fill out as much of the table as you can. And if you need to refer to the last lesson when we were trying to find different values, again, different features of the graph from the equation, then do so. But again, try and fill in this chart on your own first before we start doing a sketch. Alright, so let's take a look here. So you should get an amplitude of 3. Remember, that comes from our vertical stretch here. Now, I know there's a negative here. Remember, the amplitude is a distance and cannot be negative. The negative tells us that we have a reflection, which is going to come into play later when we make our graph. Okay, let's just hang on to that for now. But our amplitude is going to be 3. Okay, our axis comes from the vertical shift. So that's going to have the equation y equals 7. Do not forget the y equals, or else you will have to lose a mark because it's not an equation of a line anymore. Okay, now for our period, remember for the period that we're going to calculate by doing 360 degrees divided by our k value. Okay, now the k value in the equation here, it's right in there. It's kind of hidden. It's going to be 1 in this case. So there's no no horizontal stretch in this case, or horizontal compression. So our period is just going to be 360 degrees. Okay, our phase shift comes from our horizontal shift, again, if the k value is factored out, which in this case it is. So in this case it's going to be right 30. For our range, we briefly discussed when we did last lesson, but we get our range by taking a look at our axis and our amplitude. So if our axis is at 7, remember that's going to be in the middle of the graph. Okay, our amplitude is 3. That means that from the amplitude we go up 3 and down 3 to get our maximum and our minimum. So that means our maximum value is going to be 10. Our minimum value is going to be 4. So our range is going to be any y value between 4 and 10. Okay, and last but not least, for our mapping rule, we should be pros at by now, so it can be x plus 30, negative 3y plus 7. Okay, now we're going to put all this together to make our sketch. Now, to make our sketch, we're going to start by creating a box here that's going to have 8 sort of sections in it, but the idea is here we're taking our cycle and dividing into quarters. 1 quarter, 2 quarter, 3 quarters, 4 quarters right here. Okay, and we're just going to put in all the key values here along the x and y axis and then fill in our actual graph as we do it. So I'm going to start with the y values first here, and again the key y values here come from our range. Okay, so we know our axis is going to be in the middle, and we know that has a y value of 7. So my middle y value here is going to be 7. Okay, doing exactly what I did up here, knowing the fact that I have an amplitude of 3, that means my maximum value is going to be 10. My minimum value is going to be 4. So all the key y values on one cycle of the graph here are going to be displayed here. 4, 7, and 10. My max, my minimum, and my axis. Okay, now I got to figure out the x values. So one thing I'm going to do first is figure out where my cycle starts. Now on our parent functions over here, our first cycle starts here at 0 degrees for sine x and for cos x. That start of that cycle has been shifted by, if we look at our case here, it's been shifted right 30 degrees. So instead of our cycle starting at 0, it's now going to start at 30 degrees. Okay, so if it starts at 30, where is it going to end? Well, it's going to end, well, if it's one cycle, it ends after a length of the period. So the period is 360 degrees, in our case right here. So it takes 360 degrees to finish. So if it starts at 30 and ends 360 degrees later, so 30 plus 360 will give you 390 degrees. Okay, so we take our starting value here, add our period, get our final value here of 390. Okay, and last thing we need to do is just finish up what goes on in these rest of these x values right here. So remember that we split up our cycle into 4 sections here. So our period is 360 degrees. Okay, if we divide that into 4, well, 360 divided by 4 gives me 90 degrees. What that tells me is that to go up each quarter of a period like I am here, I'm going to have to add 90 degrees to the previous value. Okay, and if I do that, I can keep getting all the rest of my x values here. So 30 plus 90 gives me 120 degrees. 120 plus 90 gives me 210. And 210 plus 90 gives me 300. And there you go. I have all my key x values, all my key y values. And once I've done that, I've done most of the work because I know where all my key points are going to go based on the fact that I have a sine graph. So this is where knowledge of what sine and cosine cycles look like. So going back to the sine graph right here, the sine graph at the start of its cycle starts on the axis here. In this case, the axis is at 0, which means for our cycle, it's going to start again on the axis because it's a sine graph. Okay, so you might want to make a note of that somewhere if it helps. So since it's a sine graph, starts on its axis. Okay, so it's going to start right here. Now, again, if you go back to the original function, the sine graph from its axis then starts going up to its maximum. However, ours will not be the same because remember that reflection I asked you to hold on to till the end? Well, that reflection means it's going to go in the opposite direction. So because of the reflection, we are going to be going down from the axis to our next key point. And then we're still doing the rest of the key points from there. So from the minimum, it goes up to our axis, then up to the maximum, and then back down to the axis. So we can fill in the rest of our curve. So what I've drawn here is one cycle. I've done a sketch of one cycle of this graph right here. I didn't have to put anything onto Cartesian plane, use any mapping rules to get the answers. I was just able to get my key points from the amplitude, the axis, the period, the range, and then get the shape from the fact that I knew it was a sine function and that it was reflected. Okay? So if you put all those together, you can make the sketch relatively quickly. Okay, it might seem like a lot to look at first, but again, once you've done a few, they become a little bit easier. So let's take a look at another one here. So I'm going to have you start off by filling in all the information in the chart on your own, and then when you're done, try to fill in the x and y values here, and then try and make a sketch from there. This one's a cosine graph, so it's a little bit different than the last one. But again, just try and fill in as much as you can, at least for the labels for the x and y values, before you start making your sketch. Okay, so push play and you're ready to go through it together. Okay, let's take a look at what you've got so far. So amplitude of 4, axis of -1, y equals -1. Period, do 360 degrees divided by my k value, which is 5, which gives me a period of 72 degrees. This one's been horizontally compressed by a factor of 5. Factor of 1 over 5. So phase shift right 25 degrees from there. Range, so again, if the amplitude is 4, my axis is at -1, so from my axis I go up 4 and down 4 to get my maximum minimum values of 3 and -5. And I have my mapping rule there as well. Now again, to create my sketch, I get my y values for my axis, my amplitude, or my range. So -1 in the middle, up 4 to get my maximum, down 4 to get my minimum. So that gives me my y values there. My cycle normally starts at 0. It moved right 25, so it starts at 25 degrees. And to go from the start of the cycle to the end of the cycle, it takes the period, which is 72 degrees. So I go 25 plus 72 to give me an ending point of 97 degrees. Okay, to find out what I go up by here, I take my period divided by 4, because I split this whole cycle into quarters. So 72 degrees divided by 4 gives me 18 degrees, so I add 18 degrees to get the rest of my x values. Okay, last but not least, I just have to create my sketch now. So this is going to be a negative, so it's a cosine graph that has been reflected. So I want you to think about what that looks like, try and create the sketch, and we'll finish this up in part 2 of the lesson.